In example 14, we are expected to work out in radians the values of arc sine minus root 2 over 2 in part A, and then in part B we shall see. I want us, before we do anything, to concentrate on what I have highlighted here in red, that any graph of y is equals to arc sine x, we have to talk about now the domain to be between minus pi over 2 all the way to pi over 2, because within that is when we have one-to-one mapping. Beyond there, then we do not have a one-to-one mapping, and it doesn't reflect an inverse function. What does this mean? This means there was a certain angle x whose sine was minus root 2 over 2. Why am I saying this? There was a certain angle x whose sine was a negative root 2 over 2, such that the range of this, which is now minus root 2 over 2, becomes the domain of the inverse. So if you ask me, of course, between the range of between this range of minus pi over 2 all the way to pi over 2, there was a certain angle whose sine x is minus root 2 over 2. That means what? If we have to concentrate on probably that range which is minus pi over 2, because this is 0, all the way to pi over 2, if we are to concentrate within that kind of quadrants, then our x should be lying within that range. But because we know all science teachers complaining, then it follows that our x is not in quadrant 1. The rule does not allow us to be beyond pi over 2, and it does not allow us to be in that quadrant also. So our x is only within that quadrant. And let us see. If we pick our calculator, we are going to talk about minus root 2 divide by 2, then the sine inverse, the inverse sine of answer is going to be negative pi over 4. So you can already see that this is already pi over 4. And the fact that it is from 0 clockwise direction already, that gives us the value of negative pi over 4. So what are we saying? That arc sine minus root 2 over 2 is actually minus pi over 4. Please don't forget, this tells us if this is now being used as a domain here, it must have been the range in the original function. So there was an angle x whose sine was minus pi over root pi over 2, and that angle is minus pi over 4, simply because it should dwell between minus pi over 2 all the way to positive pi over 2, and because sine is positive in the first quadrant, therefore it must appear in the fourth quadrant. And because it is minus, then it is going towards the clockwise direction, because you know this is the positive direction and this is the negative direction. So it qualifies to be minus. But we don't need to put negative there, because already the direction tells us where we are headed. If you look at part B, the arc cos negative 1. That means there was a certain angle x whose cosine was negative 1. So there was a certain angle x whose cosine was negative 1. But you can see the range. The range is from 0 all the way to pi. So if we can easily construct or sketch the graph of y is equals to cos x, you'll see pi over 2 and pi there, you'll find something like that. So there was a certain angle x whose cosine was -1, and it's very clear. You can see the angle whose cosine was -1 is just pi, so x is equals to pi, and you can just easily talk about -1. Shift cosine of -1, you're going to get that our x is equals to pi, or arcsine cos -1 is equals to pi. What about part C? Part C tells us, what about arc tan √3? Again, it tells us that there was a certain angle x whose tangent of x was √3, was actually √3. But again, what is the range? You can see the range from -pi/2 to +pi/2, because that is when that graph has an inverse. Beyond those ranges, then it does not have an inverse. So if we talk of there was a certain angle x whose tangent was √3, then we are talking of from -pi/2 all the way to pi/2. Again, we are concentrating in those two quadrants. So if we take probably √3, and then we say shift tan answer, we are going to talk about pi/3. There was a certain angle x whose tangent was √3, and that x was concentrated between these two regions. And because we know in this region all trigonometric ratios are positive, only the sine there is positive, only the tan there is positive, and only the cosine there is positive, and our √3 is positive, so we are simply talking about our angle existing in the very first quadrant. And what is this angle? Pi/3, or rather a third pi. So in other words, the arc tan √3 is pi/3. Please note these ranges are very important, or these boundaries are very important. Only when we have inverse, that is, these are the regions only when these functions have inverses. Beyond these boundaries, then they don't have inverses. But the most important thing is to note that what we are being used to find, for example, if we can go back to example A, what we are being asked to find is there's a arc sine -√2/2. It tells us that now in this position, -√2/2 is being used as a domain. That means in the original function, it was the answer, it was the value of y, it was the range. And that is why we are already saying that to solve this, we must realize that there was a certain angle whose sine was this, -√2/2. And if we can maneuver this way, then using the boundaries, then we cannot go wrong. Okay?